this app is add more passkeys, and the reason for that is because this is a local first solution, there is no server, and therefore, if you want to have backups to get into your account, it's highly suggested that you have multiple passkeys in order to do that. So here I'm just gonna say add a passkey, and instead of using this iCloud keychain to store my passkey, I'm going to cancel and actually use my Chrome profile to add another passkey. And then I'm going to be prompted to do that. So now a second passkey has been added. So I have two passkeys stored with my account. So as you can see, I have credential 1 and 2 here for each of the passkeys that's registered with the account. So now let's say I can log out. And when I log back in, I can choose to use either the passkey that was originally created on the iCloud keychain or on my Chrome profile. So this is the second one. So I'm just going to go ahead and use the second one. And again, I'll be prompted and I'm logged back in. And as you can see, here's the secret message that has been encrypted. So no one can see this data once you're logged out, only after you have been logged in through the WebAuthn API. All right, so that's the little quick demo. Like I said, this is very early concept. So Jans, Kyle, and I have still been working on this, and this is definitely far from something that's production ready. But we definitely would love to hear any feedback, and hopefully that this is something that can push us in the right direction to coming up with a local first authentication story for the LoFi community. All right, so back to you, Jans.
Hi. So thank you for quick introduction and thank you for inviting me to talk about Evolu. So I should start the screen sharing here. I hope all you see what the first. Do you see that? I think you see. Yeah. Okay. So let's talk about. I'm sharing my slides. Okay. Okay. But it will.
Okay, just give me a second.
And now.
Sure. Okay. I think you've got. Can you hear me? Okay. Should I try sharing my screen? How's it look? You see the presentation?
Okay, so Evolu is a local first platform designed for privacy, ease of use, and no vendor lock-in. And why I made it? Why I made Evolu? So I was making some front-end application, and I was always bored when I had to make some backend for that. And uh, well, I once made an application for sharing things among friends, and I realized I need to end-to-end encryption. And then I realized I needed application have to work offline. So that's how I found the local first concept, and I was immediately uh, in love. And so I decided to make a library for myself maybe 2 years ago, but not doing it for myself only, but also I have a business use case. My friends from Satoshi Labs they have a Trezor hardware wallet, and they sold roughly few millions of those devices, and they have a real problem. They need to store labels and some user data, but they don't want to see those data. Long story short, the Evolu is designed for that use case. Satoshi Labs is a great company, and so that's why the Evolu is so strict about privacy. But the second reason is also I don't want to see the data of my clients. So another reason why I made Evolu is I want to have a control over the entire local first stack I use. Actually, there is no local first library or framework I would use with peace of mind. Or maybe there is, but I'm not aware of that. And definitely there wasn't 2 years ago. Also, I like functional programming, design patterns, simplicity, and with Evolu, I can learn and validate these concepts on a real project. And that's very rare in the corporate business world. So the Evolu is also my vision how such a library should be written. And the last line, I want to demonstrate to people what local first is meant to be, because I think there is a confusion what local first is. The term local first is so overloaded with various interpretation, misinterpretation, and even disinterpretation that it deserves some explanation. And what local first means for Evolu, the primary is data ownership. So it means all data are stored in local database, not a subset, not a cache. Otherwise, those data would not be mine. Also, there's privacy, and encryption isn't an option, it's mandatory. That's the design decision, and I think it's aligned to local first mission, because if some third party can see my data, it's not entirely mine, because all these eyes. So privacy is encryption isn't an option, and privacy is mandatory. Also, no vendor lock-in, and complexity is also lock-in. And last but not least, open source. It must be open source. And it's curious, there are so many projects local first nowadays. And some of them are even closed source. And I don't think you don't own that software if you don't own the source code, naturally. And the last paragraph, if you have sync logic on the server, you are not local first, and you don't need local first. You are actually the opposite of the local first, because how would you sync two devices locally without a server? So maybe the local first is some buzzword. It's the same with that everything is AI nowadays. And uh, every cryptocurrency is Bitcoin, even it isn't. And so it's quite often for people to misinterpret and disinterpret the terms. So that slide is important to me to explain why Evolu is designed, how it is designed. And now go to Evolu features. Not all, just I picked some features. SQLite to me is a must, or PostgreSQLite from the electric SQL guys. but it must to be database because the the application needs databases. I will talk about it later. CRDT for managing changes without conflicts, of course, it's necessary. End-to-end encryption and for sync and backup. And should say, I should highlight that the Evolu has free sync and backup server, or you can run your own. Uh, the another design decision for Evolu is that database must be typed. Typed SQL queries, typed schema, typed from TypeScript. It's super important for migrations and for safety. Local first is slightly different than classical client server, because if you will make a mistake, you can't magically fix some distant device. So we have to be careful, much more careful than with the classical client server. So types definitely helped, and if you don't know Kiseli, the project, for you should definitely check it. Kiseli is a wonderful library. Uh, and I could talk hours about that, but I'm trying to. This talk should be really short. Uh, One important Evolu feature is there is no sign up, no login. Uh, the only thing you need is a Bitcoin like mnemonic. It's generated 12 words. Even a user ID is derived safely from that mnemonic. So I would say if there is a sign up, a login, it's not local first, because sign and login means that some third party has to validate you, and that's not local first. So in Evil application, there is no sign up login, and I can demonstrate it on an example. So I will reset client database. I will change some data, and here you can see the mnemonic generated safely on your device, which can be used to restore your data on your different device. So there's no sign up, there's no login. It's those terms comes from client server world, and we local first people don't want client server. So no sign, no login, I think is unnecessary and evil and even bad. The one of the features of the Evolu is one of the main feature is not blocking the main UI thread. Evolu uses two web workers, one for DB operations and the second for synchronization and encryption. It's very important to not do performance costly things in the main thread, and Evolu doesn't do that. Okay, let's talk about the Evolu server. Evolu server is actually a very simplified Evolu client. The whole point of Evolu server is it's another Evolu client that is geographically distant to be safe for backups and always online. The Evolu server is generic for all Evolu clients. It does not require configuration or maintenance, it just works. And it's written with TypeScript, so no esoteric language is involved. There is a free Evolu server, Evolu World, and open source Evolu server for Node.js. So there's no vendor looking to me. My vision is that Evolu World should be free for all personal usage, like Signal messaging is, because Cloudflare is so cheap, and I plan to fund it by selling Evolu hardware devices. I will talk about that later. Interesting technologic challenge is how to protect the service without against misuse if you don't have a sign up and login, and Evolu will use proof of work concept, because we do not collect emails, we don't need them and we don't want them. Why should I know your email to write you, hey, try us? No, I don't care about that. Another interesting design, Evolu design is Evolu is using the effect library. It's a quite new, even it's developed In few years, it's basically Zio ported from Scala to TypeScript, but it's enriched for TypeScript. In fact, it's actually functional programming, but they do not sell it like that because functional programming jargon is scary and often unnecessary. Uh, Functional programming is really great, but the biggest problem with functional programming is those academic concepts which really are not needed. I highly recommend everyone of you to try Effect. I believe it is the future standard library for TypeScript, and Evolu is written in Effect, and I currently refactoring to use Effect even more because it's so rich, helpful, and beautiful, and they are adding APIs I need in Evolu, for example, typed access for web workers and broadcast channel, which I need because I'm currently adding to support more multi-tenancy support, the ability to run more Evolu instances concurrently and dynamically. The use case is to be able to join Evolu shared space without a commitment, so my personal data won't be affected. Imagine it as a joining and a Discord server, but with all local first bells and whistles. This is a feature. It's prepare for collaboration feature. I will talk about the missing Evolu feature soon. What about Evolu future? There are three domains: Evolu Dev, which is open source stuff about the Evolu, Evolu Evolu AI for business, paid hosting, universal sync service, and Evolu Me. I will talk about the Evolu Me in the next slide. It's everything up for all data a human can produce. A human, I mean me. uh, as I said, Evolu collaborates with the Satoshi Labs Trezor hardware wallet, and I would like to leverage that ecosystem not because of Bitcoin or even shitcoins, but because Evolu needs the proper encryption key management. We can even have more secure and private messaging than Signal because of dedicated hardware. But I will not go to the details because it's still in the making. Evolu missing features. Not everything is great with Evolu WebSockets. Evolu doesn't use WebSockets right now. Evolu is using classical fetch, HTTP request. Uh, Evolu temporarily mimic real-time in the same manner as Versal SVR does. So it does not harm UX, but of course we should use WebSockets, and once I will have a time, I will switch that implementation. Collaboration. Many collaboration software tools exist, but almost none of them are local first because local first collaboration is hard. Collaboration is pretty easy if you have a central server, but that's also not a local first design, obviously. So local first collaboration is both a technical and economical problem. It's technical problem because of encryption. End-to-end encryption is very expensive, very expensive because there's no server that could encrypt data for us, naturally. It's also economic problem, but that's for another slide. I have no time to make right now. But Evolu will definitely will use rich collaboration, but it will be quite different because of. Oh, are you calling me? Hey, hey. Hey. You were calling me. You were calling me. I promise. Yes, but you were calling me. Otherwise, I will not pick up. Okay, so let's finish. Let's finish the talk. Uh, so Evolu missing features. It's a collaboration. It's because it's harder than a classical client server pretending that is local first. Also, Evolu doesn't use AutoMerge or Loro. The thing is, we don't need it yet. For app development, Evolu prefers SQL, but I believe we can combine those concepts, and we will. So I will show you quickly what it is. It is calendar app I made by myself, for myself, but also it's open source. It's fun thing. I combined Apple Calendar with Apple Notes, and my plan is to combine all those applications I'm using. I want all my apps to be open sourced and local first, so I started with a calendar in Notes. I often use a calendar for Notes and Notes as a calendar, so I suppose it should be just one app. I believe that apps are just artificial and arbitrary boundaries within my data. They are. While Evolumi is in its early stages, I'm already using it. I believe the main flaw of all to-do reminder notes, etc. apps is the lack of calendar view. The time matters most. It's probably because it's not easy to make a calendar app, but that feature is a must to me, so that's why I started with a calendar. Making Evolu also helps me to evaluate Evolu design, developer experience, validate also features, etc. etc. It's open source, everything, and I think that's all. Last words. Evolu is meant to be simple, not a black box with no human without a PhD can understand. The core CRDT is based on James Long CRDT for Mortals talk. I recommend, you probably know that, but if you know, you should check it. And it's explained in detail in Evolu documentation how the CRDT works. It's very simple, but it's not a bug, it's a feature. The whole Evolu code is typed more than you probably know is possible because of effect. We have typed errors, etc. And whenever I'm making some important decision, I explain all the trade-offs to make Evolu accessible to everyone. No developer should use a local first framework if they don't understand how it works. That's what I believe in. Complexity is a vendor lock in too. So thank you for your listening, and feel free to write me what do you think and ask for questions and etc. Okay, I'm done.
Okay, great. Thank you. Do you want me to just share on Zoom or should I try Discord? Okay, let me try that. Okay, it's working. Great, and you can hear me well? All right. Okay, so today I'll be talking about local first state management using PowerSync. So the intersection between local first and state management is a topic that some other folks have touched on in their talks here at the local first meetups before. But it is a domain that is rapidly evolving, and I figured it's worth it for me to focus on in light of PowerSync. Before I get into that, I just wanted to give a quick introduction to myself. So I'm a developer who, in 2009, along with my co-founder Ralph Kistner, founded a company which came to be called Journey Apps. Journey Apps is a rapid app platform. So the reason why we started the platform was that we were in touch with a group of entrepreneurs who had partnerships in place to build enabling tech for community healthcare programs in sub-Saharan Africa. So there were various software use cases around programs for endemic diseases, which required a ton of customization of data models, workflows, and business logic. So that became the genesis of the platform. And we had our first customer who provided the real-world testing ground. And a big aspect of the platform from the get-go was that we needed a bidirectional data syncing engine capable of dealing with relational data. So the apps built on the platform were going to be used primarily in environments where users are offline or have poor connectivity. It is a multi-tenant platform. Every tenant schema is unique. So, and in most use cases, each tenant has too much data to sync to all mobile clients. So we had to solve dynamic partial replication. So we built the syncing engine in a generic and dynamically configurable way using SQLite on the client side and MongoDB on the server side. And then we expanded our customer base and found success with large industrial customers, mainly because of our data syncing capabilities. So those customers have workers who often work offline in remote areas and so on. And there was a talk earlier where Neftali talked about boring offline first. So I would say boring offline first is actually a good way of summarizing what Journey Apps has been doing for the last 10 plus years. And of course, there's a lot of overlap between offline first and local first. And we aspire to bring PowerSync over time closer and closer to all of the local first ideals. But this has been a very good trial by fire. It has helped us mature our core technology because of the need to keep track of various aspects of equipment production and human labor on a large scale. There are many complex use cases with scale in these industries. And over the years, we've had many people tell us that they would be interested in using just the sync engine that we've built. So they wanted to include it in their own app stack. So that prompted us to spin off PowerSync as a standalone product. We've always been focused on SQLite on the client side, and we decided to focus on Postgres on the back end because it's so ubiquitous and because the prominent sync engines that we were aware of at that time were seemingly mostly focused or all focused on NoSQL, such as CouchDB, PouchDB, and Realm. So with that introduction and background, let's get into the meat of the topic. So I wanted to start by focusing on just the aspect of doing local first state management with a SQLite database on the client side. So it's no secret, of course, to anyone here that more and more web apps are already using SQLite through WebAssembly, and that's definitely bound to grow significantly. In this talk, I'll focus on React, but the same principles will apply to most other frameworks. So with React, regardless of which state management framework you use, you typically have this one-way flow of data between state actions and the view. So the view, so the page and components, is rendered from the current state and then re-rendered whenever the state is updated. And the view can trigger actions such as button clicks, for example, which update the state. And there's various differences between the state management frameworks on a high level as well as granularly in each of these different parts of the data flow, but on a high level, the kind of broad principles apply. So if we instead use a SQLite database for managing state, the data flow is very analogous, as you can imagine. So we store the state in the application state in a SQLite database. Actions become SQL statements, so insert, update, or delete statements or more complex transactions. Reading the state is done using a reactive use query hook, which automatically updates the results whenever the underlying data changes. And in other frameworks than React, you would use the equivalent to this hook. For example, use query might be a watch or subscribe API instead. So once you have that architecture in place, you get sort of the full power of SQLite for your state management. So the state is automatically persisted across page reloads. The database handles change detection for us. We can use plain SQL queries and views to filter and transform the data as we like. And we can use fast local queries to load any data from any component. I think I'm preaching to the choir here. I think a lot of folks are familiar with these benefits, but it's once you implement this, it's really kind of a light bulb moment to see how this sort of transforms state management. So we can look at a practical example here. So I'm going to take the trusty example of a to-do list app that manages lists of tasks. And in this example, we're showing lists on the left and tasks in the selected list on the right. And then the list on the left also includes a counter of pending and completed tasks for each list. And the idea is that those should be updated as soon as you toggle any task on the right-hand side. So then to create delete or toggle tasks, we can use simple SQL statements. This is what would normally be actions in a state management framework. They become simple writes to the SQLite database. And then for our task query, we use a simple select statement with a where clause using that reactive hook that we talked about before, which automatically updates the results when the underlying data changes. These code examples assume the use of PowerSync. So you'll see the hook here is called use PowerSync watch query. I'll say more about that in a minute and talk about other equivalents as well. And then for our lists query, we also use the use query hook. And because we have the power of SQL, you can see that we can easily do things like subqueries and aggregations, such as counting, which you can see here. And that's basically all there is to it. So whenever, once you have this wired up, whenever a task is added or removed or toggled, the tasks and the list components are automatically re-rendered with the latest state. So it should be clear how state management is fairly simple in this paradigm. And yeah, so I wanted to talk a little bit more about the use parsing watch query hook, because that's, of course, at the core of what makes all of this possible. Without that, you would need to keep track of when queries are stale and need to be rerun, which would increase the complexity quickly. So this kind of API is, of course, not directly part of SQLite, but it's built on top of functionality that SQLite already includes. Specifically, we use the SQLite update hook. That fires a notification whenever a row is inserted or updated or deleted. It does provide the affected row ID, but in the PowerSync implementation, we only keep track of changed tables. And then the SQLite explain keyword. So if you give it a query, it tells you which tables are read to produce the results. And that works with anything from simple select statements to complex joins, subqueries, views, or common table expressions. So combining those two, we can rerun a query whenever data in one or more of the underlying tables have changed. And it works with practically any SQLite query. It is worth noting that this implementation does do more work than what is strictly required. So in our to-do list example, the tasks query will be rerun even if only tasks in a different list are modified. But in practice, SQLite is so fast that it doesn't matter for most use cases, and you already get large benefits from the simplicity and flexibility of this approach. So we focus on the PowerSync implementation here, but the same concepts apply to some of the other sync solutions. So for example, Electric SQL has use live query. It parses the query in JavaScript to get the underlying tables, which does impose some limitations. For example, it doesn't work for views, but it does cater for the majority of queries. And then CR SQLite / Vulkan has use query, which uses the SQLite tables used function to get the underlying tables for the query, which is similar to the explain keyword. It has a more stable API, but it's not available in many SQLite builds by default, since it has to be enabled using a compiler flag. So in our examples so far, we've used plain SQL, which should be fine for developers already familiar with it. But one disadvantage, of course, is that it doesn't give you any type info for autocomplete or build time error checking. So to handle that, we can use something like the Keasley Query Builder to get type queries and results. It is slightly more verbose in some cases, but it does give you full TypeScript type checking for the query parameters and results. Now, we don't recommend using database queries for any and all types of state. We generally recommend using queries higher up in the component hierarchy and then passing down the results as properties to components lower down. This allows us to load the data efficiently for multiple components in a single query. So in the to-do list example app, you saw that we had a single query to load all lists and their associated task counts using subqueries instead of an individual query for each list. For things like transient local component states, such as the name of a new task as the user is typing it, you can use React's use state. And then once the user saves the task, you can save it to the SQLite database. For navigation states, such as the current page or currently selected list, you can use root properties. For transient global state, you could use a temporary database. You could use React's use context, or you can minimally use state management frameworks. And that should typically be a small part of typical apps once all your persisted state is in the database. So loading states and waterfalls is one area that is worth solving. So with the asynchronous nature of database queries, there can be a flicker on the first render of a component. So it will render the results once before, it will render once before the results are available, and then again after loading the results. And then and the other associated problem is waterfalls. So when multiple components in the hierarchy each load their state, that can lead to a waterfall in rendering. And if you're retrieving data over an API, that can introduce significant latency. So when you're loading from SQLite, individual queries typically take less than a millisecond to complete. So we can run dozens of queries sequentially between 2 rendering frames. That does reduce the waterfall problem, but there can potentially still be flicker. So what we've been working on is using React Suspense for this. It's quite a decent solution so far. With very minor code changes in the app code, you can render a fallback component, such as a loading spinner. You can also use React start transition or use transition, which will let React keep the current components until the queries have loaded before rendering the new components. And that's often just for a single frame, so it gives the appearance of loading the state instantly. We have a POC example here. I included this GitHub link here. That's a PR on the PowerSync JavaScript mono repo showing how Suspense can work in one of our demo apps. in the React docs, you'll see that the suspense only works with suspense-enabled data sources. So in that PR, in that draft PR, we make our use parsing wash query hook suspense-enabled. And the next step is for us to determine how to roll that out, for example, by publishing it as an alpha version or making the suspense-enabled reactive hook available separately. So in the examples so far, we've worked only with client-side state, with the client-side database. There's no consideration of server-side state, so that's the next logical thing to look at is synchronizing with server-side state. And of course, there are multiple off-the-shelf solutions available now to keep the SQLite database in sync with the database on the server, using sync layers such as PowerSync or Electric SQL or CR SQLite/Falcon. And that obviously that certainly has huge advantages, which I think many of you are already familiar with. So of course, no individual API request needed to read data, don't have to worry about caching and cache invalidation, and the application or site can work fully offline. Now, this talk is specifically about how you would do all of this with PowerSync. So I wanted to take a minute to explain how PowerSync works. In some of the other local first web dev presentations, it's always interesting to understand the design objectives and design trade-offs of each solution. So I hope that this is useful in that sense, seeing kind of how we architected PowerSync. So I'm going to start on the Postgres side. So PowerSync connects to any Postgres as long as you're able to enable logical replication. It doesn't make modifications to Postgres, so it is loosely coupled to Postgres. You don't necessarily, for example, have to use the same schema on the client side and on the server side. You can transform the schema. Then there's the PowerSync service. It connects to Postgres, reads the logical replication stream. And then in the PowerSync service, you define declarative sync rules, what we call sync rules, which control dynamic partial replication. So the sync rules are grouped into data buckets, which allow sharing data between users where applicable. The buckets can use parameters from the user's JWT authentication token. In the sync rule definition, the developer can then write a set of SQL queries that can retrieve additional parameters from the database, as well as retrieve the actual data to be synced to users. And then the other major component of PowerSync is the set of client SDKs. So there's currently SDKs available for Flutter, React Native, Web, and then we have Kotlin in Open Alpha. Then once you include the SDK in your app code, there are a few things to wire up. So you define the schema of your local SQLite database. That can be automatically generated from your sync rules, which in turn references your Postgres database. So you can automatically generate that. Then you have to wire up a function to fetch a JWT token from your backend, which the PowerSync client SDK can then use to authenticate against the PowerSync service. So PowerSync assumes that there is some kind of backend with an API that exists independently of it. With that JWT token, the client SDK can then connect to the PowerSync service and is able to start syncing the relevant buckets of data to the local SQLite database. And that data is kept in sync in real time when the app is online using HTTP streaming. And then the last thing that the developer has to wire up is a callback function that persists writes to their Postgres database via their backend application. So we wanted to keep the developer in control of how writes are applied to Postgres via their backend. In that way, PowerSync only requires read-only access to Postgres, and it allows the developer to apply their own business logic, fine-grained validation, fine-grained authorization validations, those kind of things, to the writes. And the PowerSync client SDK will queue writes and then attempt them using the callback function defined by the developer. So that means that if the user is offline, writes will retry until a network connection is available. And then from here on out, the developer can just read and write to the local SQLite database using the capabilities such as the reactive live query hook to update the UI in real time. So PowerSync does use a server authoritative architecture. So it doesn't use CRDTs in its protocol currently, but for fine-grained collaboration, you can store and sync CRDT data structures using PowerSync. And then after a write is processed on the backend, it'll be replicated to all clients and they'll all converge to a consistent state. The PowerSync client SDKs are open source. The PowerSync service is currently a hosted service, and it's currently closed source, but a free source available self-hosted version will be released within the next couple of months. So taking a step back and considering state management on a high level, using SQLite for state management is a relatively new approach. There's more work required to cover more use cases, higher data volumes, low latency rendering, and performance in general. But I think this is going to be a rapidly evolving area in the next few months, and we're going to see some really interesting new tech that will increasingly, potentially even displace a lot of the state management framework functionality. even right now, it already works for a pretty large share of use cases. And it's, when developers start developing with local first paradigm, they often observe that it's a nice benefit to this architecture. There was a developer in our community who recently tried out PowerSync, and he made the following interesting observation. He said, back in the days of building web apps with forms and whole page reloads, we mainly wrote code that worked with SQL databases holding state in the backend with useful properties like ACID transactions. Now with modern web apps, there's been a Cambrian explosion of different approaches to managing state, and each library and framework has its own flavor and mental model. With Wasm SQLite and local first sync layers, isn't it great that we can go back to just working with a SQL database that holds our state? And yeah, that's a wrap. So I can be reached here, and you can find PowerSync at powersync.com. And yeah, thanks for listening.
Hey, can you hear me okay? Should I try to share my screen in Discord again, or did you want me to do it through Zoom? All right, let me try sharing my screen here. Can you see it? Give it a second. Okay. Yes, thank you for having me, everybody. I appreciate it. I am muting and not sharing on Zoom. I'm going to share my screen. So let me know. I believe that you're still sharing. Just the window's fine. Oh, okay. Got it. Well, then hopefully you can see this presentation. If you're seeing Discord, then it's the wrong screen. I wasn't able to choose what to share. There we go. Okay, I think we're good now. Okay, how about now? Great. Well, thank you, everyone. Pleasure to be here. I'm Adam, the founder and CEO of FourThink. FourThink is an application, and well, I think we have some cool tooling under the hood. I'm going to focus today's talk on, the motivation behind this. We are building something that is meant to aid recall of all the things that we've seen and done and to resurface them when they're relevant again. This is sort of mirroring some ideas from cognitive science about how we experience the world and why a lot of that tooling in our brain doesn't translate to the digital. Just by way of brief background, how I got here. I was originally a quant at a hedge fund before moving into tech, where I was in an org where after managing several dozen people across different teams and even different departments, it became a real challenge to try to stay on top of everything that was happening. There would be multiple projects, there would be different departments to coordinate with, and it wasn't all just in and out of me. It was across each other as well. And there's frankly just a lot of switching context throughout any given day. It's just today's project B and project C, and then tomorrow D comes up, and it's just a constant stream of stuff that's in one ear and out the other. And so the feeling of what that's like, I was just essentially information overload and trying to remember what was I just doing, what was I supposed to do right now, and what's coming up. It's sort of just keep swimming and trying to stay on top of everything. Now, The reason I think that this happens is just because in the digital world, it's a constant stream of two-dimensional screens all day long. The average knowledge worker is switching apps and websites over 1,000 times a day. That's a recent Harvard Business Review study. And for some roles, it's even much higher, but just, on average. And every time you're switching something, it's sort of a little bit of the intention from the last task is carried over in a residue. This is attention residue. And that can accumulate like plaque, making it very hard to sort of, remember where you are and what you're doing. Now, in the real world and the way that our brain evolved, we have this region called the hippocampus. It's a sort of oddly shaped structure in the middle of the brain, and it's responsible for the formation of episodic memory. And this is sort of the, sequence of events that happened. And it's using that, especially as you're moving through an environment, that helps to maintain a mental representation of space. And there's just a whole bunch of things that you might just have sort of muscle memory that, like, what drawer were my pants in. And the interesting thing is that people that are constantly navigating a space, like taxi drivers for example, have an enlarged hippocampus because they're forming a lot of memories of the space and where things are, and it helps them to navigate. Just a little more on memories and how they form. There are a few different components to this that are basically the intersection of space and time. And there's this baseline brainwave called a theta rhythm in the background. It's like a universal clock, basically. And then there are these special neurons called place cells, and these essentially light up at specific locations. And so, in this example here of just a mouse moving through, a maze or whatever, you see sort of these different colored regions that are like different, place fields, with the dots sort of lighting up as it's in that area. And as these neurons fire in a specific area, the timing of the firing shifts earlier and earlier in the theta cycle so that it can sort of be almost like an inverse Doppler effect that allows it to sort of begin to build a sequence, tracing a sequence. And so it's this very interesting intersection of, movement over time that creates this spatiotemporal compression that essentially we call memories of where we've been, and that helps us to figure out where we're going. Now, what could a digital hippocampus look like that would help us make sense of all of the, different things that we experience digitally throughout the day? We have what we call records, which sort of unify all the sort of heterogeneous document types like email and messages and documents and websites and presentations, meetings, all these different things that people do and are very fragmented across different services or silos and share a lot of relationships that just aren't recorded anywhere. And so it's almost like a librarian who's creating a card catalog of, what everything is and how it's related. You kind of want to be grouping these fragmented records into, this higher level abstraction. And that then can help create situational awareness. So, you can essentially remember where am I? What do I need to prepare or finish a task or meeting for, wherever I'm going? When did I last speak to this person that I'm about to meet with? What did we talk about then? You want to be optimally aware of, the context that you're in or what's coming up. Now, a sort of basic assumption around how a brain or a body navigates an environment is that, it's embodied. It has essentially a sense of self and perception of the environment. The most interesting thing about local first to us is that it essentially has that sense of embodiment that it has to be on the device. It has to start from the device and not essentially, have some giant umbilical to a server that's really doing all the work somewhere else. And you really want, as your device is navigating this digital environment, to be able to perceive, signal from the noise because of the thousands of things that stream in one ear and out the other. There's a lot of noise. And so how do you sort of figure out, the needle in the haystack? We like some examples from biology here. Nature's approach to finding signal from noise, I think, has some really interesting examples from sound or acoustics. And one example is echolocation in dolphins, which are, pinging the environment to hear echoes that help them identify where things are. And that's actually unique among the senses for exerting energy into the environment in order to sense what's out there. Another example are spiders, which obviously use their webs in order to sense what's around them. That's essentially an extended form of cognition. They are able to not only sense the vibrations through the thread, but they can tension particular threads by stepping on it to create more tension and really sort of focusing on what's happening in that direction. And they can learn from this in order to alter the construction of their webs based on what they remember and the cues in the environment. You can see in this sort of heat map of a web here in the side view that different things like a mosquito or a cricket or a bird interacting with the web create these sort of different fingerprints that allow them to identify what is happening over there. Now, Think really kind of wants to almost be like, the spider, but we've already got this web. There's a lot of stuff in the cloud, in Google. I use Gmail and, a lot of their services. We've got Slack, we've got, GitHub. There's, obviously a lot of people that are using Microsoft or many other different SaaS apps that are scattered all over the place. And you kind of want this second brain that is mostly on your device but is able to leverage a lot of what's available to you as if that's the distributed processing that's happening elsewhere, and you can be aware of it and it's sending you the signals as things happen, or you're pinging it actively like a dolphin to see what's out there. But that sense of a sort of second brain really needs, I think, to encompass everything, not just notes. It's got to be your emails and all the different messaging services and being able to tie everything together. We have a Chrome extension right now, or browser extension, any Chromium-based browser, that is basically able to see the sources of these records from all these APIs by directly connecting devices to APIs. And the background scripts and the service worker are doing a lot of the work around pre-processing and indexing. We use Rust and WASM and IndexedDB locally. And then obviously there's content scripts for the sort of presentation layer. We think that some of those ideas from the way that nature uses acoustics are super interesting for how efficiently they can compress information. And so it's sort of like we're able to ping these APIs in real time in order to understand what is relevant to a search or to how we define the current context, or as you look at a sort of timeline of activity, we can be constantly sort of seeing what's related to this conceptual landmark right now. And that is essentially stored as linked lists in IndexedDB that can be quickly pulled together into a subgraph, which is really part of what we consider a hypergraph, because all these links or edges are metadata and other sort of derived things that can skew across many. So we're looking at sort of overlap between lots of co-occurrences in order to see how clusters of things, like when I was looking at LoFi here, and we could see the timeline with lumps of activity, and even see it sort of over a calendar, different records and a bunch of emails, calendar invites, website visits, and just a sense that there's some lines that are sort of connecting those dots. And of course, all of this is stored locally, and Forthink sees 0 kilobytes of user data. Going forward, we are really most focused with some of our enterprise customers and how we work, in particular in regulated industries like asset management and legal people that are very hesitant to share any confidential information and feel like it's just a requirement that things need to be handled either locally or within their own private clouds. And of course, they do want to leverage the services they have, but the important thing is that we never see their data. And so that really makes much easier to sort of establish some relationships with these folks, and being able to help them drill on particular tasks and use cases where there's a lot of cognitive overhead, like I've experienced trying to remember what you need to do for this upcoming thing, or ensuring that information is optimally propagated throughout the organization, because there's so much that is available to you via API that you may not even certainly not remember or not even know about, and you want these things to surface right where and when they're relevant. So our ultimate goal is to be able to use this sort of timeline of everything and the ability to retrieve what's relevant to a current context or upcoming context to really predict what you're going to need and fetch things proactively. Let me just to give people a quick glance here, zoom out and just, here's the Chrome extension and, recent topics, lo-fi. Here's the presentation. Here's Discord. Here's the meeting invite. Here's the Canva for the deck they want me to look at. Here's the Twitter. Here's an email that I guess was related to a comment on the deck. Here's some notes I had going into it. There's just a whole bunch of stuff here, and we want to be able to not only find things related to that, but have different features that allow us to sort of group and see these things over time. So just looking back on my last day or so, there's exploring extended cognition in spiders, preparing for the talk, echolocation, developing forethink itself. There's stuff like that, and so I'm happy to dive into any more of it when people want, but I appreciate everyone's time and attention. Thank you. Yeah, as Monty Python said, and now it's time for something completely different.